Hey students, welcome to lesson 8.4. Let's get rocking into this wide world of composite figures. Now, I know you have already studied composite figures in 8.2 as it relates to perimeter, but this time around, the objective is to find the area of composite figures. So we're going to extend what you were starting in 8.3. Okay, so with that being said, let's direct your attention to this screen. So, the key ideas today is going to be a little bit extended, so I'm going to speed up the video a little bit and just get to the end result. So bear with me on this one, but basically you need to know a lot of different formulas from the past. They're old formulas you've seen before, and then a couple adaptations of ones that you may not quite have. Okay, so with that being said, let's go ahead and look at this. Alright, and I am back. So what you should notice is that there are four basic shapes that we should know by now. Most of them are standard from across the years, but just want to kind of clarify. So we will have to remember all these formulas, especially as it applies to the different composite figures. Now, don't forget about the circle one too, and I intentionally left that out now because you should already have known this from last section, but just to kind of keep it in mind, it's the area of a circle is pi r squared. And let me redraw that because that is a very ugly circle. Okay, that's much better. All right, so with that being said, the only thing I want to kind of point you towards is the square and parallelogram. Square, remember all the sides are the same, so if I just call each one side s, the area is s squared. But don't forget, you can use the rectangle formula for a square. It's base times height or s times s. Parallelograms are the odd shapes. It's those kind of angled looking shape that seems skewed just slightly. The actual height has to be perpendicular to the base. Okay, so whenever you're looking at a parallelogram, double check that the height that you're using, and that's why I'm going to highlight this right here, it is a 90-degree angle to the base that you choose. Okay, so that's just a little bit of carefulness with parallelograms that we have to make note of. Alright, so with that being said, let's move on to example set 1. Double check that you have all this information in your notes. Okay. So for example 1, we're going to look at the grid coordinate system like we have done in previous set of problems. The key thing here is that what I recommend is splitting up the area into different composite shapes. Yes, you can count the different squares and find the area that way, but note that if you look here, there's a couple half pieces. And those half pieces, and sometimes they're even odder depending on how the lines are angled, aren't very intuitive. So what I recommend is splitting it up into specific shapes that you know. For example, I noticed right away that there is a triangle right there. I see another triangle right here, and then this bottom is an entire rectangle that can be easily found, and then at the very top, and I'll try highlighting that in a different color, is a lovely looking square. So this is where you can use a little bit of intuition to split it up. There are a couple ways you can split it up. Don't think this is the only solution, but you can easily count those half squares, but I feel it's better if you just split it up into the different shapes. So with that being said, I'm going to do a lot of this kind of in my head because the grid system is pretty smooth. This bottom rectangle is 4 by 8, so that's going to be 32. It's 4 by 8. This right here is 3 by 3, but remember it's a triangle. So our formula is base times height divided by 2. So it's 3 times 3 divided by 2. 9 divided by 2 is 4.5. This is a lovely looking square, and so that's easy to count that there are 9. And this last triangle is 2 by 2. So it's going to be 2 height, 2 bottom base. 2 times 2 is 4 divided by 2. And that becomes 2. So my actual overall area is just the summation of all those parts. 2 plus 9 plus 4.5 plus 32. And at this point, it becomes just a calculator question. Okay, so, but the key thing to remember is that you have to split it up into different parts. Okay? It's not always intuitive, okay? But you have to be able to visualize the different parts, and there's many ways you can split this up. For example, I could have split it up even more by going ahead and making this entire piece and getting rid of that square at the top, and now we have this piece, and this piece. But that's not as smooth with the calculations. I like to see if I can split it up into the smallest amount of parts. Okay. All right, so with that being said, that's the conclusion of this example. Okay, take a moment to write it all down as needed, review it, pause, and then we'll move on to example set 2. All right, so example set 2 is split up into 2 parts. Okay, so 2 examples, and they're both going to go ahead and showcase the gist of what I expect you to do again. Okay, the key thing with these shapes, once again, just like I said for the last one, is we want to make sure that we can split up the parts appropriately. Okay, so in the first one, I noticed that there's a square, and then there seems a rectangle, that is, and a circle. And more specifically, okay, if we're trying to find the area of this entire inside, don't let that whole circle fool you. It's actually going to be a semicircle added to a rectangle. So this is where we got to be extra careful. So I'm going to go ahead and, just for organization, I'm going to go ahead and do the calculations for the semicircle and the rectangle in nice organized method. So going back to yesterday's or a couple days ago's work, semicircles A equals pi r squared over 2. And then finishing the rest off, we got pi times the radius. Now the radius, notice the radius, it's give us the diameter because it's the same length as 12 here. We're going to use 6 for the radius and finish that off. So let's go ahead and quickly, that becomes just calculator math, 36 pi over 2. Okay, and that's approximately 56.55. I'm still going to go ahead and use 2 digits or hundredths. The rectangle is much smoother. A equals base times height, and in this case we got 19 times 12. That's too big for my brain, so I am gonna go ahead and use the calc, and it comes out to be exactly 228. So my overall area in this case, okay, area total, I'm gonna use this nice little subscripting, is 56.55 plus 228. So at this point, right, this problem is complete. But the key things to note is just to make sure that you can break apart the composite into its appropriate parts. Okay, and don't forget units being feet squared. So this problem, very straightforward because there was only 2 parts. The next one, okay, there are 3, and I'm going to set it up and then speed the video along so you don't have to see all the calculations, because really the core thing here is you need to be able to go ahead and split up the different parts. So in this shape, I see a triangle right here, okay, triangle, I see a rectangle, and then definitely a parallelogram. Okay, so I'm going to split up my work once again into triangle, rectangle, parallelogram, keeping it as organized as possible. All right, at this point I'm going to speed up the video so you don't have to see the overall calculations, and then I'll break down anything that is needed. All right. And I'm back. So what you should see in front of you are all 3 shapes fully realized with the substitution and the formulas. Okay. Note that organize your work when doing the composites. That's the key thing. It's not that finding the area of a rectangle or even a parallelogram or triangle are all that difficult separately. It's putting it all together where we start making mistakes if we don't organize things or we don't write down everything appropriately. Okay, especially getting the correct measurements from the shapes itself. Like for the parallelogram, notice that it was 6.7 was the height because it was perpendicular or at a 90-degree angle to that base. Okay, so everything on here that you see on the screen, this is about the maximum level that you'll probably see, other than the shapes changing and the numbers change. The core things about composites are what you see in this example. Okay, so pause this video at this point if you need to, but let's move on to the OYO in just a second. All right, for the on your own, there are only 4 that I would like you to try. There are definitely some challenges with a couple of them, especially like say number 4. But if you notice, there's a lot of repetition of parts, so you want to go ahead and use that as a way to simplify and organize your work appropriately. So at this point, go ahead and pause the video as needed and look at the work, do it on your own, and then in about 10 seconds I will show the actual answers magically pop up. Alright, the video should go ahead and showcase all of the work appropriate for these 4 problems. Note number 1 and 2 can have different solutions and how you solve it. The answer will still be the same, but notice for number 1 I split it up into 2 tall rectangles and then the triangle. And then for number 2 is a little bit trickier. There are some trapezoids in there. I didn't really lay out trapezoids, but any trapezoid can be really split up into triangles and squares or rectangles. So if you notice, number 2, I split it up into 2 triangles over on the left side and the rectangle, and then there's a couple triangles on the right. I did that intentionally because noticing the symmetry, I went ahead and decided to just multiply those answers by how many there are. So 4.5 times 2, 6 and 24 comes from the rectangles, and then 4 times 2 and then 2 times 2 because there were that many shapes. So look for that repetition and it can definitely help you. For number 3, very straightforward, triangle and rectangle. Note that the base of the triangle was 9 because I transferred that dimension from up top. And then for number 4, it looks crazier than it is, but it's actually only 2 shapes. The semicircles are pi r squared over 2, okay, as we did in last section, but it came out to be a very smooth 1.57, and I multiplied by 4 because there's 4 of them. You could have also found the area of 1 full circle and multiplied by 2 because those 4 semicircles are equivalent of 2 whole, and then the square in the very center. So take a peek at this, make sure that you got it. If there are any questions, obviously take a moment to go ahead and email me or review this video as needed. Okay, so hopefully you enjoyed this. All right, in your Big Ideas Math Online, I will have the 8.4 lesson practice available for you. Okay, and 8.4 is technically the very end. So if there's anything that you still need to review or catch up on, now's a good time to go ahead and do that. All right, thanks for watching.